Hi everyone, this is section 4.1 day 2 on special binomials. Yesterday, and this is for integrated 2 KC8. Yesterday we did factoring binomials. Today we're going to have special binomials, okay? And more specifically, it's called the difference of squares. And I did mention this before earlier in the unit, and we're coming back to it today. So a difference of squares, so think about that, the difference, what operation do you think of when someone says the difference between two things, right? The difference is associated with subtraction. So you are going to subtract two perfect squares, okay? Remember that we also talked about perfect squares, right? Those numbers that I get when I square another number, like what the totals are. So 1 squared equals to 1. So 1 is a perfect square. 2 squared is 4. So 4 is a perfect square. 3 squared is 9. 9 is a perfect square, okay, and so forth. Okay, this will not work with addition, okay? The difference of squares has to be two perfect squares being subtracted. It will not work if it's two perfect squares being added together. That is prime. You cannot factor that. And then your final answer. Now before, and I can show you guys from problems before, okay, just like C, when I factor out a binomial by my greatest common factor, I have one set of parentheses and something outside of the parentheses. For these special binomials, you're actually going to have factors in two parentheses. So it's going to look like this. It's going to be in factored form, which again, we covered a little bit last unit. So, for example, I have to factor each binomial. Okay, so what I want to do is I want to think about my perfect squares, right? So this is already a perfect square because x is squared. That's what you want. So x squared, I'm just going to rewrite. I'm going to bring down my minus sign. Now I want to think about 9 as what number squared will give me 9. Okay, well the answer to that is 3. 3 squared is 9. Now, since both of these are squared, all I have to do is rewrite these two terms in my final answer. Okay, so it's going to be split up into two parentheses, and because it's squared, there's two x's, so one in each, and two 3's, one in each. Now the signs in between those, one of them is going to be positive, one of them is going to be negative, and I'm done. This is factored form for difference of squares. It's always going to be one positive, one negative, and it doesn't matter which way you write it, okay? You can also write it as x minus 3 first and x plus 3 second. It does not matter because multiplication doesn't matter what order you put it, right? 1 times 2 is the same thing as 2 times 1. All right, next one. X squared minus 25. So x squared stays the same. It's already squared. Minus what number squared will give me 25? Well, that would be 5 squared. Now, if you're not sure, you can always do the square root of that number, and it will give you a whole number if it is a perfect square. All right, so x and 5 is what I have left over. So I have x plus 5 and x minus 5 as my final answer, and I'm done. Now, let's see. Now, 3 and 4 are a little different. Okay, and you will notice that you have a number in front of the x squares, and that's okay because 4 is also a perfect square. So not only am I going to have x to be a perfect square, I'm also going to have 49 and 4, because what number squared will give you 4? Well, the answer to that is 2. 2 squared. So I have 2 squared, x squared minus 49 will be 7 squared. So now I have 2x as one of my terms and 7 as my other one. So I have 2x plus 7 times 2x minus 7, and I'm done. Go ahead and pause the video, and I want you to try number 4. All right, 16. It's the same thing as 4 squared. Bring down the x squared minus 121 is 11 squared. So now I have my two terms, 4x and 11. So I have 4x plus 11 and 4x minus 11.